Assalamu alaikum dear students. So welcome to today's lecture, and which is about chapter 5. So chapter 5 continues, but there is a little twist. In last few lectures we were talking about different titles and definite titles, how to evaluate, how to define, and everything was all about the definite titles. But in this section we are going to learn a technique to evaluate indefinite values, and that method is called substitution method. And why do we need to learn this method at this point of time? Because in next section we are going to find areas between the curves. So this method is going to help us finding the definite integrals as well. So let's start. So here is the rule, the substitution rule. Using this rule, how to evaluate an integral. So if we have an integral of this type, that is, if we can write it as f of gx d prime x dx, then we can make a substitution. Gx is equal to u, and then this integral will become this integral f u du, and then we can solve it by using any technique of taking antiderivative. So, for example, we can have an integral of like this, x cube plus 1 into x square, or you may write 2x square as well in order to make it obvious. So if we compare it with this, so this is actually f of gx. Gx here is x cube plus 1. So it can be written as f of x cube plus 1 into derivative of x cube plus 1. It must be 3 here. Okay. So derivative of x cube plus 1, which will be g prime x. So f of gx. Gx here is this. So g prime x, that is derivative of x cube plus 1 dx. Okay. So if we make a substitution, x cube plus 1 is equal to u. So x cube plus 1 is u. Then what about dx? So we have to convert everything inside the integration, that is the integrand. We have to convert the variable x in every term in u. Okay, so this is the first rule of transformation. If you make a substitution, you have to convert the old variable into new variable. Okay, so keep it in mind that you have to convert this differential into new differential. So if x cube plus 1 is equal to u, then 3x square dx is equal to dt. So this is how the whole integrand is converted into u. Now it can be written as, by this making this substitution, integral of u into du. And now we can use the power rule. It will be u square divided by 2. And ultimately we need an answer with the original variable, so we have to do the backward substitution. So by backward substitution we have x cube plus 1 square divided by 2, and of course plus c, because two antiderivatives differ with the constant. So this c is very important, and this is also called constant of integration. So x cube plus 1 whole square divided by 2 is the answer. Okay, so this is one way. This is a simple example. So let's try a bit more complicated example to understand the method. So here is the first example, and we are going to solve few questions in this section, and nothing else. So first question: find the integral of this x cube plus x to the power of 5 into 3x square plus 1 dx. Okay, so this is gx. In fact, x cube plus x is the gx, and this is the derivative of this x cube plus x. Okay, so this is g prime x. So let's make a substitution. let x cube plus 1 be, sorry, plus x be equal to u, then taking differential, we have 3x squared plus 1 dx is equal to du. Okay, so this integral will become now integral of, since this is u to the power 5 into du. So now this is very easy to uh, 1 divided by 6 plus c, that is u 6 divided by 6 plus, but we need an answer in terms of x. So this is because of indefinite integrals. Indefinite integral, in case of definite integrals, the procedure is a bit different. We'll learn in next section. So in case of definite integrals, we have to find the answer in terms of x. So by backward substitution, u is equal to x plus xu plus x. So we have x cubed plus x to the power 6 divided by 6 plus c. So this is the answer. Okay, next question. Find this integral. So again, our gx here is 2x plus 1. So we are going to substitute it equal to u. So in order to find the differential, 2 dx is equal to du. So this integral becomes square root of u, and this implies actually, because we have to plug into value of dx, so dx is du over d, so du over 2. So this is 1 over 2 square root of u du. Now we have to integrate this. This is equal to 1 over 2 u 1 by 2 plus 1 divided by 1 by 2 plus 1 and plus, of course, classes of integration. So 1 by 2, this is u 3 by 2 divided by 3 by 2 plus c. Okay, so this is equal to 1 by 3 u 3 by 2 plus c, and this is equal to, now backward substitution, this is time to substitute backward. So 1 with 3, 2x plus 1 to the power 3 by 2 and plus. So this is the answer. Okay, try next question. So we have a question here. Secant square 5x plus 1 multiplied by 5. Okay, what to do? Alright. We know the antiderivative of secant square x. Okay. So if we have u somewhere here, then we can find the antiderivative. So how to make it u? We substitute it as u. So let's make a substitution that 5x plus 1 is equal to u. Then by taking differential, 5 dx is du. So this is quite straightforward. Secant square u is du. Okay, because 5 dx is equal to du. Now this is equal to secant square, integral of secant square, that is antiderivative of secant square u is tangent u, and plus c, of course. So this is equal to tangent of, backward substitution now, tangent of 5x plus 1 plus c. Okay, now next. Well, there is another example, cosecant square 2 theta cot 2 theta. So what to do? Okay, let's try. Well, there is a relation between cotangent and cosecant square. Cosecant square is derivative of what? Okay, So we can substitute cot 2 theta as u. So let's do it. If we end up with something complicated, we can change the substitution as well. So this is sometimes hit and try. So let cotangent to theta be u, then minus secant square 2 theta into derivative of 2 theta is 2. So we will have 2 here. D theta is dU. So cosecant square 2 theta d theta becomes now cosecant square 2 theta d theta is minus du over 2. And now by plugging in these values, this integral becomes cotangent to theta is u, so we have u. Cosecant square theta d theta is minus du, so this is 1 equal to, because this is constant, so we are left with u du. Okay, so this is equal to minus 1 over 2 u square divided by 2 plus c, that is we have u square divided by 4 negative u square plus c, and this is time of backward substitution. So we have cotangent 2 theta square 2 theta divided by 4 and with negative sign plus c. So this is the answer. Okay, this is even more complicated. 18 tangent square x, so you have to find the value. Question is same to find 18 tangent square x secant square x divided by 2 plus tangent cube x whole square. So there is a lot of happening actually. So what to you can actually assume 2 plus tangent cube x as gx. You can assume tangent cube x as gx, or you can also think of substituting tangent x is u as gx. So let's see, I am going to try with tangent cube. Okay, so as I told you earlier, if we end up with some result which is quite complicated and we cannot handle that result, then we will get back to the question and try another substitution. So let's try tangent cube first. Okay, let's tangent cube x be u. Then what is going to happen? We have to take the differential 3 tangent square x into derivative of tangent, which is secant square x dx is du, right? So 3 tangent square x, okay, right, du. Okay, we need 18 tangent square. 18 can be taken as common outside, or 18 can be written as, because we need 3 inside, because 3 tangent square secant square dx, we know the value of this is du. So 6 3s are 18, so we can take 6 out. So 6 3 tangent square x secant square x divided by 2 plus tangent cube x square dx. And by this substitution, this becomes 6 du over 2 plus u square. Okay, and if we had substituted 2 plus tangent cube x as u, it would have been even easier, right? Yeah. So we should expect it more than one substitutions for one integral. So 6 d2. Now making this substitution, we have this integral. Now we have to solve this, and it can be solved by the power rule. So this is equal to 6 2 plus u minus 2 negative 2 to the power negative 2 du. Okay, this can be written as this. Now apply the power rule for integration. 2 plus u minus 2 plus 1 divided by minus 2 plus 1 plus c, of course, and this becomes 6. This is minus 2, negative 6 minus 2 plus 1 is negative minus 6 over 2 plus u, because minus 2 plus 1 is negative 1, so we have minus 6 plus c. Now by backward substitution, we have minus 6 over 2 plus tangent cube x, because u is tangent cube x according to our substitution, so plus c. So we are done. So that's all for today's lecture. You can practice more questions from the exercise. So I hope this is very easy to understand, and you can do it yourself very well. Take care. See you in next lecture.